pull up a chair, take out the oxygen, and join the discussion.
You've just stepped into Life Unculturable,
the world where conversations grow faster than colonies.
We're your hosts, Sam and Julia, scientists by day,
Podcasters by night,
and professional oxygen avoiders 24/7. Join us in exploring the science of microbes that thrive in the absence of oxygen on Life Unculturable.
Well, hello and welcome to the next episode of Life Unculturable. Sam and I are back in the chamber. We're well caffeinated, well fed, and ready to roll. And before we tell you what the topic is, maybe I'll ask Sam how he's doing today.
I was going to say, very bold of you to assume that I'm well fed, well caffeinated, and ready to roll, but...
I mean, at least I saw you jugging your energy drink, so caffeinated we got covered.
No, I think for the most part, I'm doing really good. I'm riding the academic high right now. A lot of manuscripts juggling, a lot of them in review, rebuttals in the wrapping up portions of things, which is always nice. Like the closing of chapters to the opening of others. And so I think for the most part, I'm doing really, really good.
That's good.
Yeah.
Well, look at you go. Favorite postdoc of the lab.
Well, when you're the only postdoc in the lab, you're by default the favorite, but you're also the least favorite. So either way, I'm seeing the pendulum swing. Yeah. So how are you doing, Julia?
I'm doing pretty well, I think.
Yeah.
A little bit sad that the chapter is closing now, because for our audience, we officially have April 2nd today, and my stint at the Yusha Head Lab ended with April 1st, which is very sad. But I'm happy that we keep Life Unculturable going.
Yes. So that is the plan. You know, we are still aiming to put out some cool Life Unculturable content. And we've still got some pretty good interviews lined up and on the way that we're excited about. We've got some really cool guests.
Yes.
And we're excited to do that, even on different continents and different time zones and all of that jazz.
Yeah.
But
I'm excited to see
that makes me tech support then, which is, this yowza.
Well, you've been doing very well so far, and today you're the tech support in charge.
Yeah,
and we were set up within 5 minutes.
That's true, but we're only like 3 minutes into the episode, so we got a lot of ground to cover. So, Julia, now that we've established that we're both good, we're both ready to go, what in the heck are we talking about today?
Well, so in previous episodes, we've told all of you guys how we pick samples, how we isolate stuff, how we enrich for stuff, and all of that jazz. But now we're at the step of we have a novel organism, either a bacterium or a fungus. Nobody's going to know which one is cooler. We all know.
I do.
But let's say we have a novel strain of one of the kingdoms. What the heck are we doing now? We're going to do a rundown of how we are profiling our microbes and how we characterize them.
I like how you said that, profiling.
Yeah, I feel like it's
being hyper-judgmental.
Yes. I feel like that's all we do.
You can't do that, obviously.
Well, some of us go from the you can't do that standpoint. Some of us go from them, oh, look what this new microbe can do.
Optimists. It's fine. Optimism. Come on now. Be like, nice try. You couldn't degrade cellulose. Loser.
Well, and that's why anaerobic fungi are the best.
And with that, folks, we're talking about characterization today. And I think just as a brief recap, when we hit that eureka moment of, aha, we have something new to science, I think that's a really cool moment. I've always enjoyed that, thinking perhaps naively a bit, but also with a little bit of pride, a little gusto, that I'm like, wow, I'm the first person to look at this thing. Whether it's under the microscope, or I'm just staring at it on a plate after I get the data back that, definitively more or less tells me that it's novel. I really enjoy that part. It's like a little dopamine, a little injection there that I need sometimes.
Yeah. Yeah, same.
And then
Completely
sometimes
agree.
It's the exact opposite feeling, though I will say this is kind of contradictory, because sometimes I'm like, wow, we found another one and another one. Sound like DJ Khaled and another one. And you're like, man, how many another ones are there? But for the most part, it's a positive feeling.
Yeah. And I think our listeners, after listening to this episode, will understand why there is maybe a little bit of ambivalence towards finding too many novel ones, because I think after listening to us talk about characterization, we will all understand how much work goes into characterizing just one strain and what we actually have to do to get it like properly recognized as a novel strain.
So what I'm hearing you say is that our listeners can clip out this audio bit and they can send it to journals when they're, submitting their rebuttals. And they ask them to do 12 other experiments. They can be like, listen to the esteemed Samuel and Julia talk about why it's hard.
Listen to them whine.
Exactly. Okay, so characterization. So we've got this novel thing. Nobody's seen it before, at least nobody's bragged about seeing it before. And then what in the heck do we do next?
We can't we have a novel organism. We know it's novel, but we can't just go ahead and, like in the next paper, say, that's a novel organism, cool, bye. We have to actually characterize it.
I think a definition that I would interject, it's one of those buzzwords, if you will, at least in the prokaryotic taxonomy, is the term polyphasic approach. And so that for me is as soon as I realize, oh, wow, I've got something new, I begin formulating this idea of this polyphasic approach in my head. Is that something that you fungal folks abide by, that term? Is that a big buzzword in the mycological communities?
Polyphasic, do you mind defining it for our listeners?
Yes, but that's going to cost you €1.
A whole euro?
Well, it's more than $1, so I'm trying to make money here, folks. Money.
I can give you a quarter.
I'll take a quarter of €1 then. Is that a thing? Do we have?
No, we have 20 cents, not 25.
Of course, we have 20 cents.
Yeah, because we go by full numbers, not some weird in-between stuff.
That's fine. Fractions don't matter. So characterization, folks. Polyphasic taxonomy. Essentially, for me, what it means in a nutshell, and I'm going to gloss over some things, so this isn't the end-all, be-all, but think of it as looking at different aspects of the organism, right? It's not just measuring phenotypic properties. It's not just genome metrics that say this is novel or a single amplicon sequence that says this is novel. It's combining those things together, and it's also considering things like the chemotype of a particular organism and doing that sort of in concert with each other. And then further, I would argue that it's diving into the literature around where you think your novel organism belongs and figuring out sort of what the precedent is for the polyphasic approach in that particular, like if it's a genus or if it's a family or whatever the case might be, and then applying sort of those protocols to look at the phenotype, the genotype, the chemotype to your novel strain as it gets described. Mm-hmm. And so that, for me, is how I would surmise the polyphasic approach.
Yeah, I think that was a good summary, even without glossing over too much. I think that was a very good summary.
Here.
But keeping our listeners in mind, because you throw out a lot of big words there.
Yeah, I do.
And
I know them all.
Sure, your mom is very proud of you for that. But she might not know what those big words mean. I mean, your mom might. Mine doesn't, because...
Mama Miller don't know those words. I love you, Mom. Shout out, Mom. I know you're listening. She keeps asking me when the next episode's coming out.
Aww.
So I know. Yep.
But yeah, just to quickly get our listeners on board there with all the big words. So characterization of a new strain. Essentially what we are doing is we are going to put together a profile of this specific strain. We are looking at what does this DNA look like? It's like genome and transcriptome maybe. What does the cell itself look like? Is it round? Is it spiral? Is it big? Is it small? Does it have weird structures on the outside of its cell or in the inside? So phenotype. And then chemotype was one of the words you also said. So that's another aspect that we're looking at, mainly talking about what kind of molecules does this strain produce or consume and stuff like that. So we are essentially building a whole, this is this microbe profile, looking at this microbe from all angles and trying to define what makes this microbe, what makes it up, what makes it.
Totally. Then that's That's a really good summary, I think, Julia. And the question that often comes to mind after that is why? Like, why do all that stuff? And
why live?
Exactly. That's what I'm saying. And so is the microbe. It's like,
why are you doing this to me?
I've been in this tube for 8 months. Help. Help. I was just in a beaver. Help. But I digress. I think like it's really important if we want to study microbes and to sort of figure out what makes them tick, what they're capable of, what they can produce, and if something is of benefit in some way, whether it's a secondary metabolite, it's an antibiotic, it's, you know, maybe it's a degradation of a particular product or, you know, the production of something else, some anthropogenic compound that we humans want to, you know, run our vehicles on or whatever the case might be.
Yeah.
It's important that we begin with a single thing and then we can very easily manipulate it. And then, of course, you know, I think one of the things that the field is pushing towards is then at some point it's a consortium type situation. And it's like now we know what we think we know about these individual units. Now let's amalgamate them together and manipulate the community to see what happens, you know, on a more realistic level. Because in truth, nothing really lives in isolation.
Yeah. Yeah. I would agree that we mostly, like the benefit to society is for sure the potential uses we could get out of the microbes. That's why it's very helpful to just describe them and also look for novel stuff. That's how we got penicillin. So that's what we do. But I would argue
please do.
From a purely curious scientific standpoint, it's like, of course, like we got this novel thing. We want to know what it does, who it is, what makes it. And we do that. Like sometimes there doesn't need to be an end goal to it. It's same as like describing a new bird species. Like that bird is cool, and there might not be an end goal to it, but just for the fun of it and the interest in like describing life in general, at least in my heart.
I was going to say, I totally agree. And that's essentially what makes us weirdos. Yeah. Because like for us, that is the cool part. Yeah. It's convincing other people to be excited about this weird, very niche thing. Like, hey, we got this new fill in the blank. And you're like, oh, cool. Like I've never heard of any of that stuff. Like, what does it do for me? You're like, well, 50 years from now, it could produce acetate.
There you go.
It's like, hey, why is this good for me? And the cycle repeats itself. But yeah, it is genuinely what gets me up out of bed in the morning. I love chasing down these little microbes. And I love it. I love it so much. And so characterizing, Julia, do you have a particular workflow that you like to go through? Like, do you want to do these type of characterizations first, or does it really matter to you at all what happens first as long as you meet like a hypothetical checklist of some sort?
I mean, by this point, we've done it a couple of times, so we found a workflow that works for us. But of course, there are more important characteristics that we really need to know. So those come first, because anaerobic fungi could just keel over and die at any point sometimes. So you want to make sure that you get as much information out of that strain before anything happens. So, I mean, the most important ones are for sure the genotyping, so DNA extraction and RNA extraction for like sequencing their genome, their DNA, and sequencing their RNA, the transcriptome. Those two are the first things that happen once we are sure that it's a new strain. Similar, like the sequencing the molecular markers that define the clades and see how they fit into whatever exists in that particular family or whatever.
That's interesting. I think I, too, would probably start very quickly with a genome in a sense that, so like for me, I'll screen, using a marker gene. Shout out 16S-rRNA. You go, girl. Is getting a genome sequenced after that. And it's sort of easier for me than it is for you. One, because the size of your genomes is so much bigger than the size of like a bacterial genome.
Yes, it is.
So if...
Mine's bigger than yours.
Well, it's what's on the inside that counts, folks. And for the most part, bacteria, it's all coding all the time. They're precious for the most part. So for those of you that may not be intimately aware about the size of bacterial genomes, We're looking somewhere in the 4.5 million to the 8.5 million sort of range of A's, T's, G's, and C's. Although there are obviously things that are less than that, and there are obviously things that are more than that, some of which I've worked with recently. It's like intracellular parasites and other things like myxobacteria that are sometimes up to like 13, 14 megabase pairs.
Cute.
I know. But as I was so eloquently trying to put it, Julia, or should I say reviewer 2, it's much smaller relative to like the fungal genomes. And so for me, I can, just bottle up some biomass or extract the DNA, ship it off to a company, and within, 48 hours, 72 hours, like I've got a high quality 50, 100-ish X coverage genome ready to rock and roll that sort of puts the definitive stamp on, whether it's novel or not. Ultimately, because we bacteriologists, the royal we here, our gold standard for what is like a new species, for instance, it boils down to average nucleotide identity and and digital DNA hybridization, both of which are accomplished with a genome sequence. And then querying that against, various other ones in a particular database.
Which is essentially gives you a number on how similar that genome is to the other genomes.
Yep. I take a look at it and it'll be like, you are not the father.
No baby daddy sequencing here.
Yes, go see that episode if you haven't already checked out Janet's episode. Shout out, Janet. You were amazing. But yeah, so I think I too would want to start with a genome, but for slightly different reasons, I would imagine. So what's the genome sequencing process look like for you with your large genomes and all those A's, T's, G's, and C's?
Well, I think by now technology has caught up enough that we might be at the same point very soon that you are at. So anaerobic fungi, the genomes are between 60 and 200 million A's, T's, G's, and C's.
Lame.
So you and your 13 can go cry in the corner. The size is less of an issue because technology has been good enough for long enough to be able to deal with big size genomes. But our fungi actually have a lot of like repeating segments. Like a lot of their genome is just repetition. And that is then hard to assemble later into a high quality genome, as well as like our fungi have a very high content of A's and T's and less G's and C's. So that also makes it hard to assemble because if you have like less letters in there, you probably won't be able to figure out what part goes where. But yeah, I think sequencing technology with the long read sequencing might be finally catching up to where it will be possible to have a similar easy workflow as you have. But for now, our gold standard is not yet the AAI, the amino acid identity, or any of the genome-based factors. We do use it because our lab, the USHAD lab, has been publishing transcriptomes with those values, so there is the option to use it. But the gold standard is still the marker gene region for now because genome sequencing is still tricky.
Yeah. So for those of you that are listening at home and you're like, what do we take away from this? I'll summarize it in one sentence. Kids.
Fungi greater than bacteria.
It is prokaryotes greater than eukaryotes.
Well.
Full stop.
I beg to differ.
Only perhaps in that regard. There we go. Ease of working with.
Yeah. Yeah, if you want to make your life simple and easy, just go with bacteria.
Yep. That was the lie I was told all those years ago.
Yeah.
Yes.
Because you have your own struggles with the bacteria as well.
Yes.
None of it is easy.
They be struggling.
Yeah.
So we've got the genome now. We both agree on that. That's probably one of the first things that we do.
Yes.
And then what, if anything, do you like to do next?
So then two things will happen at once. So there will be the start of the chemotyping. So we will figure out what our fungi are using, usually substrate-wise, like what they can eat. We don't so much, like there's no requirement for us to include what they produce really yet. In that sense, our fungi are actually easier because with the little amount of information we have, there's only like so much you could even compare to current literature. And the main thing that everybody's interested in our fungi is their substrate utilization, because that is what they're good at. They can degrade a million different complex carbohydrates, essentially plant material. That's why we are interested in them on a biotechnological scale. So that's what we try to include in characterizations. So yeah, we figure out the substrate utilization and maybe even the temperatures they grow in, because that is like something you also want to start very soon, because again, our cultures tend to heal over and die.
Yeah.
But you also want to do microscopy, figuring out what they look like, what their sporangia look like, what their filaments look like, their zoospores. Are they producing any other like sexual reproduction kind of structures?
Hey, this is a family show. Easy. Binary fission is what we do over here.
Yeah, because you
Get out of
are
here with this.
unimaginative and vanilla, where everything is just binary.
Whatever the heck else is going on in these crazy eukaryotes, swapping DNA with each other. I mean, I suppose we play that game too, but it's slightly different. It's fine.
I mean, we're not the ones having peelies sticking into each other.
Well,
just saying.
It's horizontal gene transfer, kids. It's all good. You got to get around to the plasmid somehow. But I think this is funny to me because this is immediately where we're going to differ on our approach. And I think part of that is going back to the idea of the polyphasic taxonomy, digging into the literature, figuring out, okay, what in this group needs to be done? Like what is given precedence and importance immediately? And for you, that's a lot of microscopy. Because like you were saying, is it bulbous or staining the nuclei? Is it this? Because it separates them very quickly into groups that share similar characteristics, which you can then further decide what else needs to be done. For me, one of the next things that I'm doing is shipping mine off to culture collections, which I know is sort of an issue for you AGF folks, and we've chatted about it in the past, is because you can't really deposit them in places. And for me, something that we'll dig into in a bit is the code. Beware the code. The code. Be more like guidelines. But the International Code of the Nomenclature of Prokaryotes, the ICNP, one of the criteria for publishing like a novel bacterial species is, hey, you've got to deposit it and it be publicly available in 2 culture collections, ideally in like separate countries. And so oftentimes, like the shipping and the lag time for me to get something from, say, like Stillwater, Oklahoma to Braunschweig or Gothenburg, or, pick a city that I'm not gonna, or a state. I'm not sure what Braunschweig is. I'm thinking, wouldn't that be like a city?
Yes.
Is that a city? Thank you. I apologize to my German brethren for dealing with that.
I love how you pronounce those. I feel like that's how we should pronounce them from now on.
I gave it a go.
So culture collection deposition is your first step.
And purely from a logistic standpoint for me, like it doesn't have to be, but I personally over the years have found that this expedites the process for me. Because once my bacteria or my single bacterium arrive at said culture collection, like it has to be taken in and processed, and then there's an individual there that has to do whatever quality metrics that they're going to do to verify it is what I say it is, as well as ensure that it survives like lyophilization or cryopreservation, and then it comes back to life so that 40 years from now some poor postdoc in Braunschweig can
Sam,
you can't teach an old dog new tricks.
If the dog is as smart as you are.
Well, most Chihuahuas. Can work with it for whatever unforeseen reason. But for the most part, again, at least in my experience, other people may have had, different things here. It tends to be time intensive, right? Like it's going to be maybe a week or so to get the culture wherever around the world that it needs to go. And then, it might be several weeks before I hear from the curator that's responsible for overseeing the deposition of this strain, say like, hey, we're working with it. And then in that point, like it may be 6 months or so before it's like officially archived at, fill in the blank culture collection. And then I receive a certificate of deposit that says, okay, Sam Miller, deposited this strain with us. And, I verify that it is what it says it is. And so I always start that process early. Mm-hmm. And
makes sense.
I actually just did that yesterday. I shipped some stuff off to, I'll just say Germany this time, to the DSMZ culture collection. Shout out DSMZ.
We love you.
If you're listening, yeah. But so for me, that's probably the next thing that I do, because I'm very confident that I have a novel thing. I can sort of prove to people, hey, based on our most gold standard metrics, yes, it is novel. I'm not wasting your time. Now, please accept this in your culture collection. So that's usually my go-to. And then from there, I probably go microscopy. And so we've kind of joked about like our favorite, microscopy techniques in the past, falling in love with SEM, or, hating confocal or whatever we were doing. But yeah, I do all the basic like gram staining and the endospore staining and, scanning electron microscopy and all of those things to try to figure out, what it is, which to be fair, most of that I get from the genome anyways, because it's like, oh, I've got a bacteroides, like it's not going to be gram positive. So, but I'm still going to gram stain it, because I'm a good boy. And I'll go through some of that microscopy. And then I think from there, I'm probably leaning into some of the more physiological experiments, because I don't rely so much on morphology. I think that was more important probably in the 70s and 80s, where we didn't have access to like 16S rRNA gene and whole genome sequencing and things of that sort. And so it was important at that point to document like, oh, it is a mid-terminal endospore producing organism. And like, where does it form? And what does the shape look like? What kind of bowling pin is it, And that's like, it's still relevant, but it's not, I would say, quite as like the hinge point of a novel strain argument as it probably used to be. And so, microscopy for me is still something that gets done, but it's slightly less important. And then to your point about the physiology stuff, I think the first thing I'm doing is temperature. Like I want to figure out where the optimal temperature is so that I can then do all the rest of my physiological experiments at said optimal temperature.
Yes.
Yeah, that's sort of my usual flow of things.
Yeah. I mean, it's not so different for us fungi because, of course, we cannot deposit our fungi in the culture collections because no culture collection will accept an organism that they have to keep alive by transferring it weekly or bi-weekly.
What? They don't do that? Why? You don't have one dedicated person on your staff to just do that for their
if you
entire life? Welcome to hell.
DSMZ, if you need a person and you pay well enough, I'm there.
Well, you wouldn't just do it for free?
No, I think I would need at least have lodging and be fed. And maybe have a paid trip every once in a while.
Could you survive on substrates from the lab? Because maybe we could negotiate this in your startup package.
So if we buy glucose for the fungi, just have an extra container for me that I just spoon.
Exactly. Like you could get, like a 50 mil conical tube of glucose like every 3 days.
Nice.
We could start there.
I think we should get in some psychologists and medical doctors to do studies on me while I'm doing this to see how much the human body can take.
Fair enough.
But yeah.
So I rudely interrupted you. Culture collections hate anaerobic gut fungi.
They do. So that's not possible for us. But of course, I want to make sure, because of the looming of an imminent death that might be happening at any point, we of course make sure to preserve biomass as soon as possible. And they're just in our lab resource. And microscopy, it used to be more important, similar to what you said, more important in the 70s and 80s when we didn't really have access to reliable sequencing and then reliable discrimination between strains. I love microscopy. I love looking at my fungi. They're pretty. They're really cool. But I do not like the importance some people put on the phenotype because there are so many fungi that look very, very similar, and distinguishing between them is just, in my opinion, just a bias. But
I agree with you there. To interrupt you, I think that when it comes to like the observation bias. Like what does, like if I'm trying to come up with a word that describes this shape, and then you are, and even if we're in the same room looking at the same thing, like I'm going to have a different description than you are.
Yeah.
As I'm trying to, like, oh, it looks like, I don't know, whatever to me. But it's going to look like something totally different to you.
Of course. And then the shape is also influenced, at least in our fungi, it's influenced by the state of their life cycle, the temperature in the room, the specific blob of biomass, the specific batch of room and fluid media. Like it's influenced by so many things. I feel like nailing down a phenotype is kind of scientifically not very sound. I mean, a general phenotype like filamentous and bulbous, yes. Where the nuclei are located, yes. But it gets tricky after that. But still, unfortunately, the phenotype is still important because of the missing genomes and the transcriptomes, like the issues that I told you before. We don't have like a lot of whole genome sequences. We still rely very much on marker gene regions. And there are some fungi that are very, very similar in marker gene region. Like they are 98% similar. But if you look at them under the microscope, they're different, like very clearly different. So we just haven't found the distinguishing marker gene region yet, I guess.
Okay.
That really clearly identifies one from the other. So phenotype is still important for our fungi, which is good and bad. I love looking at them, but it takes hours and hours on end to get every life stage.
Yeah. I also think it's interesting, at least to me, how we quantify like the utilization of particular substrates. For instance, if we're talking phenotype, like with bacteria, I think it's pretty straightforward for the most part because you stick it in a tube, then the tube gets cloudy, and you can just quantify that cloudiness over time. And there's obviously other ways that you can measure this too. It's not always turbidity. There's some cultures that they don't do very well in liquid media, and so they'll grow at the top and they'll clump, and so OD's kind of you're not doing OD at that point. You're doing it in some other way. But yeah, you fungal folks, when I first got into the lab and I saw you like jabbing it with that pressure gauge, I was like, what kind of nonsense is this? That was absolutely bananas to me, because you're just jabbing that little bike pump down in there and seeing like how much gas they've produced and trying to... Yeah, that's wild. I guess to me, the difference between how each of us is to say, yes, it uses glucose is so different, but still like almost equally valid.
Yeah. I mean, our fungi suffer from the same issues that you mentioned. Like OD is not going to help you because they clump. So you have to find another way. And luckily, they produce hydrogen. So you can measure the accumulation of hydrogen as a approximate for growth with its own pitfalls and flaws, of course.
We need like a bulge tube flamethrower. Pop one off and poof. Like that should be the measurement, is how high does the flame go when you pop the seal off? Is it above or below a certain threshold?
Did it burn down the lab or no?
Exactly.
Nice.
Yeah. So, I suppose, Julia, we're due a lab yap. And you have so eloquently already emailed me 16 times about what that lab yap is going to be. So
I'm sorry, I feel very strongly about that.
Well,
as I do about every of our lab yaps.
That's why we have this segment. So
yeah, so I feel like this segment has turned into a therapy session for me and some of our guests, but rarely you. Like, you never have something to get off your chest.
Well, I do every once in a while, but I'm a pretty easygoing guy for the most part. I'm just here for the ride.
You just yap about it while we sit at our desks with no microphones, which is still a crime.
Yeah. Oh, that's probably a good thing. We don't need microphones at the desk. We have taken up enough space in our OneDrive folders without the extra audio recordings.
I think I checked it when I copied everything around. I think our Life Unculturable folder is now at 57 gigabytes of data.
What? I thought it was 18 gigs.
Oh, really?
Is it so much more? I mean, I believe that. Maybe it was 64 or something instead of 18. I don't really do mathematics, people.
Those numbers are easily mixed up.
Works for me. Maybe that's my lab. Yep. Math.
I do confirm you've yapped about it before.
Yes.
Just with no microphones present.
Yeah, I think on the same episode you bashed my handwriting and made fun of something else. So what do we need to get off your chest, Julia? And I'll just casually agree with you, unless I disagree with you.
Okay, I think in line with our episode today, I have a topic that I feel very strongly about, and that is, so our viewers for sure know that as scientists, we have to pay to publish. Like, we don't get paid if we publish a manuscript.
What?
We have to pay. And not a...
How am I just now hearing about this? Oh, I'm sorry. Please continue, caller.
And it's not an insignificant amount. I mean, there are journals that are only $900, but there are journals like up to $18,000 is this so-called APC charge. Are we correcting? Up to $12,000. Up to $12,000 or $13,000.
Yeah, I just wanted to see what the gold open access charge for Nature, according to an AI here, folks, that we are not sponsored by. Yeah, $12,700 USD.
For one manuscript, mind you. Like for one. And I mean, yeah, you only have to pay it when it actually gets accepted for publication. But I mean, come on. That is a whole lot of money for, they say it's like for the data storage and the review process and the quality control and whatnot. Mind you, other than the editor in a review process, nobody's getting paid. Nobody's getting paid to do the review. And then still we have manuscripts to this day that have very, very specific formatting requirements when you want to submit the manuscript. As in, it has to be a specific, sometimes even a specific font size. It has to be structured in a very specific way, not as in like introduction, methods, results, not that kind. I mean, that's fine. But structured as in the heading has to be this specific heading and it has to be like indented this specific amount of pixels and whatnot. And what annoys me the most, the absolute most about all of these formatting things is they always require you to format the references in a very specific way. And that is not my job. I mean, what is the editor for? What is the whole editing process for? I'm not a freaking editor. If you want your references to be formatted in a very specific way on your journal, so you have like continuous formatting across all your articles, you have to do that. I provide the manuscript and the data and everything, but you have to do your part if you want those $12,000 from us. That's my feeling. Sorry. You can tell it's a hot topic.
So it is at this point, folks, that I would like to tell all of the people at the higher up echelons of academic publishing that we're not picking on just one journal here.
No.
By all means, please accept my manuscripts because I need a job in the near future. But
it is very much a systemic issue.
Yeah.
Still to this day.
Yeah, that is interesting. You would think that by now there's probably some sort of, even like an AI that they could pop in a bibliography to. And
not even AI. I mean, we had
very, very quickly.
We had this technology forever before AI. Like, there's no need for us to reformat it. You can do that. You can deal with that.
Yeah. I will say some journals in my experience have, how do they word it? It's something to the effect of like less formatting at first. But then more formatting later on.
Yeah.
So it's like submit it now, and then we'll give it a glance over, and then we'll get back to you on how to reformat all the specific stuff.
That makes me even more mad than the journals that require specific formatting up front.
Correct.
Because it's just like they lure you in with false promises, and then you still have to deal with that. With that shenanigans.
Sorry, we were trying out sound effects here. Okay, so let me recap that lab yet for those of you that have glazed your eyes over. Julia hates formatting requirements. She hates the journal. And why do we format citations?
I don't know. I feel like I should just give them a list of DOI links and they should figure it out. Yeah. And I mean, it's not like we're actively, like I think you should cite in a way that they can figure out what manuscript you're citing. But I don't see why I need to care about the formatting, whether it's like Vancouver style or APA style. Like, come on.
Yeah. I'm inclined to agree there. Yeah, I'm inclined to agree. And I think, too, the difference between journals, not that I think that all journals should be the same, because at that point, I mean, you have just one journal. You don't have variety that is the spice of life. But but some of the ones, like say if you're writing a sentence that's, you know, like previously these things have been found, whatever, and you're going to cite like 4 or 5, you know, publications like in the in-text portion of this sentence. And then instead of just doing like 4-7, like how it'll wrap it up together neatly like that, it's like Johnson 2019, comma, you know, Helsinki 2042, and it just keeps, and it gets so long, and then your manuscript is like 12 more pages because everybody has a long last name.
Oh, so Sam's lab, yep. It's not that we're generally hating on formatting. You just hate on specific formats.
There we go. That seems reasonable.
Nice.
But if you think about it, you get maybe and it's probably, what would it be in the grand scheme of life? Like an extra, maybe a paragraph, maybe a half paragraph. It's not like it's going to increase the publication by 5 pages. It's probably.
But it makes it less readable.
5 or 6 lines. The readability does go down for me. Yeah. Yeah. It's kind of a turn off.
I do agree, but then when I read manuscript in like my specific field, and I kind of know probably all of the manuscript because the field is so small, I very much appreciate to have it called, I don't know, Hanafi et al. 2020 instead of number 4, because I don't have to go look what number 4 was. I know Hanafi et al. 2020 is the paper about the 7 new genera. Shout out Radwa.
There we go. If you're listening, we appreciate you.
Yes.
Tell your friends. We hope you have friends. Tell them.
She for sure has. She's such a cool person.
Did you ever meet her in person?
I never met her in person.
I don't think I've met her in person either.
No. I've met her online a couple of times, but never in person. I'm very sad about that.
Well, her loss. Man, let's see. Anything else with that format? Oh, I hate how with certain journals, you have to then go and build a PDF at the end of the thing. Apparently there is a consensus in the chamber. But so for those of you that may not be intimately aware of this process, you know, you don't just upload your manuscript with your figures in a Word document and then Bob's your uncle and it's off to the races. It's, you know, load the specific manuscript, like all the formatting things that Julia's been talking about. And then it's like, oh, upload your figures as separate specific types of files. Upload your supplemental material in a specific way as a specific different type of file, formatted a different way. And then, you know, at some point in time, like in my case, we're going to talk today about we've been talking today about characterization. Part of that process for me is depositing in culture collections. And so each one of those isolates is going to have at least 2 certificates of deposit that also needs uploaded in a specific type of file format. And so you've got maybe sometimes 15 to 20 different files that you're uploading. And then at the end, it's like build PDF and you just cross your fingers and hope the moon's in alignment. And it's never right on the first time.
No.
And then even when I submit it, it's still wrong. Mm-hmm. And then I get an email from the journal saying like, hey, resubmit this because this part was wrong. And I'm like,
you have to reformat your references.
Yes. So there's that. There's that. And one that gets me flagged a lot is like whenever I sign up with the journal online to like be the submitter of said manuscripts and like create an account with them, oftentimes I will fill in like my middle name. Mm-hmm. So it'll be like Samuel Lee Miller. And then on the manuscripts, when I submit them, it'll be Samuel L. Miller. And then it's like they don't match. And I'm like, what are we doing here? Just because at the same time too, like your org ID, like that's usually in there, and it's like that's me at this point.
Yes.
You know,
I feel like there should be a way that the system can figure out that Samuel Lee Miller is in fact the same person as Samuel L. Miller.
But to defend these people, I'll play devil's advocate here. There are quite a few Samuel Millers out there in existence, some of whom are very esteemed microbiologists. So
there's another Samuel L. Miller.
Oh, yeah.
A microbiologist.
Oh, yeah.
Bleep that guy. We have the only one and true Sam Miller.
Here we go. Look at that. Dr. Miller, blah, 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 does
Salmonella.
Stuff. Yeah, so let's see what we got going on here recently. See, look at that.
Human genetic variation reveals.
Still active. But the point being here, there are other esteemed Samuel Millers that are also microbiologists out there in the world. And so...
But there's only the one and true Samuel Miller on uncultivated microbes on the Finding Genius podcast.
That's right. Whoop, whoop. Come on. Yeah.
But yeah, that's the issue of having a non-unique name, which I very much envy you for. I would give anything to have a non-unique name. Because if you Google my name, you will find every little thing that has ever been published in my name.
There we go. That should be a challenge, folks. Figure out what you can dig up on Julia and me and send it to us. Let's go. Good luck. Buena suerte.
My only one consolation is that the internet is producing so much data at this point that we're losing. I don't know. I forgot what the number was, but I think it was 10 to 20% every year. So maybe that all of that important data on this one Austrian mycologist gets buried in 1 year.
Nonsense. Man, what else is that? So yeah, that's a solid lab yap. With that, Julia, is there anything else that we should yap about today that you're feeling super strongly about, or is one ranting session enough for you?
I think the 1 30-minute ranting session was quite good.
30-minute ranting session?
21 minutes,
well,
sorry.
Well, folks, if we're rounding, it's not bad. Not bad.
But no, I just feel like we could get back into our very cool topic today and yap about some more characterization.
All right. In that case, I suppose, back to the episode.
Well, we've gone through all of the little bit, the general categories that we look at, like temperature, phenotype, genotype, and chemotype. So you've mentioned there are rules or guidelines on new strains. Like, what do those rules and guidelines include?
Boy, I think that would be an entire podcast channel in and of itself.
Oh yeah, Article
especially
22.
for the prokaryotes. So and I do appreciate it because there's a bit of structure that's been given to the process, and I think that helps us as scientists. It gives us sort of some guidelines and some rails to kind of go between. In the rules, the ICNP, it's fairly regularly updated every couple of years or so. Like a new one just came out maybe a month ago. Just an update of the code kind of helps with facilitating the naming of things. Like, you should name things a certain way with certain Latin, Greek, the masculine, feminine, that sort of stuff. There's rules in there that govern those things. There's rules that govern, like, for instance, for me, I need it deposited in 2 different culture collections. I need to have a whole genome sequence. I need to have such and such data in order for it to be considered meeting, like, satisfactory standards. And so all of those things for me, which there's a lot. There's several revisions of the code, as it were, over the years. But those things ultimately make it into a species description, which I think is something we both wanted to touch on, because that's sort of like the conclusion, if you will, of probably our manuscripts when we describe something that's new. Is it's like we tell you about, where it came from and how we isolated it and all the things that it can eat. And then the species description is like the bio, essentially, of the
summary of our
summary
profile.
of it. Yeah. Where we'll include things like, what are its optimal conditions? What can it go between? Like, what are its tolerance limits? And where is this data available?
Yeah.
And that sort of stuff. And so, a lot of my manuscripts wind up ending with, species description.
Yes.
Yeah. And then even, explaining how you named the particular thing. Like, I named it this because it came from an alpaca, and this is the Latin derivation of, whatever.
Can I name a bacterium whatever I want?
I think if you can justify it, you can do it. I think it would be frowned upon in some establishments. But for the most part, I think you could probably finesse your way into naming something a certain way. Short answer, yes. Long answer, it's slightly more complicated, and it would be semi-frowned upon.
Oh, interesting. Well, in the fungal world, we also have an international code of systematics that includes the eukaryotes in general. And similar to what you were saying, it like defines how you would have to go about describing a new species. It defines what the rules on naming are. And that goes as far as like you have to have the right connecting vowels between two words in your name. It has to be like if your words in the name are Greek, it has to be an O. If they are Latin, it has to be an I and stuff like that, which seems silly when you first stumble upon it because you think like that seems nitpicky. But it kind of makes sense that they like try to have the whole process be like organized and streamlined and there be rules so that you don't end up with all those weird names that we're still stuck at that were given to some of the animals in like 1700.
No, exactly. I think that's important, and especially too is it's probably not as applicable to like anaerobic fungi, but I start to think about like clinically relevant like bacteriological maybe pathogens or something like that. And like they have particular genus species names, like C. diff, for instance. It used to be Clostridium difficile. Now it's Clostridioides difficile. And so you go through the naming process and you go, oh, well, it's not really a Clostridium, right? And so like even if you're trying to rename things because they don't technically belong where they were originally placed like decades ago, like there still needs to be some consideration given to the derivation of the new name.
Yes.
Right? Because you don't want to then all of a sudden have like clinicians and other people that are it's like, what is M. diff or whatever it is, like it's been C. diff for forever. Like it still needs to be C. diff, but it needs to be corrected in some way. And so, yeah, I do like that there's, again, sort of guiding principles that can help us do things in a right and in a meaningful and impactful way.
Yes.
Yeah.
Now that you said in a right and a meaningful way, is there a wrong way to publish a novel strain?
So that's an interesting question. I don't want to say no. But the systematics person in me. So for instance, I'll just talk to the bacterial people out there because I don't be knowing nothing about fungi. There is one particular journal, so that's IJSEM, the International Journal of Systematics and Evolutionary Microbiology. So shout out to folks at IJSEM. We bacteriologists have essentially agreed that your new strain needs to be published in that journal in order to be considered validly published. All things standards of the ICNP go through the IJSEM. Now, you can publish your novel microbe in other journals. So the difference there is like a valid publication versus an effective publication. And so like if something's published in like Current Microbiology or PLOS One or wherever, Nature, like it doesn't matter where. If it's not in the IJSEM, it's like it doesn't technically exist to us in the literature when I'm thinking about stuff. Mm-hmm. And so for those of you that are out there that are like, oh, well, I'm publishing it in, whatever, Current Microbiology or wherever, it doesn't matter. It's great. Do that. Follow the rules. Do good science. But then when you're done, there's a way that you can submit your manuscript to IGSEM, and then essentially someone just revalidates it. Mm-hmm. They're like, oh, it meets the ICNP standards, so therefore we validate it. And then they have these what are called like validation publications every so often throughout the year where it's like, oh, these, 50 or 60 taxa, they were published, between such and such date, and they all meet those criteria. We validated that, and now we're going to take them from being effectively published to validly published. Mm. And then they'll be essentially recognized as existing in the literature, having gone through that process.
Nice. Okay, so there's no really wrong way to publish. So if I go and I take a bacterium that I've isolated from my yogurt in the fridge, and I don't do genome sequencing on it, I just do microscopy on it. Yeah. And I've tested if it grows on my carrots, on my strawberries, on my smoothie in the fridge. And then I go and submit it to the New York Times saying I've discovered this very novel organism.
Yeah.
There's no wrong way to publish?
No. So that, yes. Yes. So in that sense, there is a wrong way. And that's sort of, I think, why that validation process through the IGSEM, ensuring that things meet the ICNP standards, is there. Because there are times in the literature where you'll read through and you'll find something about a microbe, And then you go to the original publication and you're like, oh, there is no data to really back this up. They just, like, maybe it exists. I don't know. Maybe it does. But as far as I'm concerned, it doesn't, because it doesn't meet sort of this standard that we hold ourselves to.
Yeah.
And so, yeah, like you could certainly publish in any journal that you want to publish in, but then it needs to be verified that it sort of keeps to the code and that it has certain things, like it has a genome, it is in culture collections, it has some of these basic rudimentary data that it needs to have to exist and be out there in the world. So I suppose there is a wrong way, but there's not technically a wrong journal, I guess. No one's blacklisted yet that I know of.
I mean,
guess I'll
probably
find
the
that out.
blacklisted journals, like the scam journals.
Well, yeah, perhaps. Yeah.
But yeah, well,
Man.
I think we've done
Is
it.
that it? We did it! Well, Julia, anything else you would like to add to this characterization episode?
No, not really. I think we've talked about like what we do, what the profile is going to be, what we're looking at, where to publish it. We've thoroughly ranted about the journals and their formatting requirements. I don't think we have anything to add other than I think writing a species description, as much as I hate it during the process of actually getting the data to describe it, sometimes I really enjoy writing species descriptions, because you can go through the literature and read up about all of these other strains that look similar or do a similar thing or are very closely related, and then just compare it. And it feels like, I don't know, I kind of like profiling.
Yeah. I guess the one thing that I neglected to say during this, and it goes back to probably more the 70s, 80s, 90s of like bacteriology, is that it used to be really commonplace to run a lot of these analyses and these experiments like in parallel with like closely related strains. It used to be very commonplace that you would then have to go and purchase closely related species from like culture collections. And then you would do like your temperature, your salt, your whatever, amylase, like all these different analyses in parallel with those closely related organisms. And so then it becomes a question of like, well, why don't you do that anymore? And I think a lot of it is like cost, time. Are we getting anything out of it? And essentially now what we'll do is like we're still delving into the literature to find out like what are these most closely related strains to like our novel strain. But, we're now taking data from those manuscripts and saying like, oh, okay, like on this media in these conditions, it does X, Y, and Z. And then we'll grow it on said media in said conditions and then try to compare X, Y, and Z. And so that's kind of nice now in a sense. So you don't have to spend like $500, $800 times 5 just to get, in your closely related strains to compare throughout the manuscript, because we already know that the APC charges are.
I feel like we are onto
through the roof.
A big conspiracy theory here.
Yeah, big micro.
Big micro, because
that's quite the
oxymoron.
IC big micro. Shout out Big Micro if you're listening. But I don't disagree.
Yes.
But yeah, that's really the only thing that I think I didn't say.
Okay.
And, but yeah,
makes sense.
So it's a lot of comparative analysis. I like your analogy of profiling. We're just profiling these suckers.
Yeah.
Well, I suppose with that, folks, we're gonna wrap the characterization episode, and hopefully you all have a better character now because of this.
And we do hope that you now understand why we think it's so much work too. Like going back to the beginning of the episode, where I totally don't remember what I said, but me.
Yeah.
How much work goes into characterization of a microbe.
So question, best case scenario, everything goes right, nothing dies 12 different times. How long does it take you start to finish, do you think, to characterize? Not like writing and publishing, but like in the wet lab experiments.
I can actually put a number on that, because our very favorite manuscript at this point in time that is currently under revision and will hopefully be accepted, where we roped you into the fungal world. There were 2 strains in there, like 3 strains we described, 3 novel genera. And 2 of them we've isolated in One of them in March 2025, one of them in April 2025. We submitted the manuscript in December 2025. So I would say three months if you do it very efficiently.
Yeah.
3 months lab work plus the writing.
Yeah. That's interesting. I was sort of thinking 3 months for myself as well. I think some of it depends on obviously like how quickly the thing grows and what it grows on. Because sometimes some of the anaerobes they be slow to the party. But yeah, I think in general I'd say 3 months. 3 months as well. That would give me time. I think for me, even if like something went wrong, like I could go back and redo it. So yeah, I'd say 3 months.
That's interesting because you do so many more of the analyses. Like we don't have to do that many different things to it, but for us it takes 3 months because they grow only within like 5 days. You always have to wait 5 days before you can know anything. 5 to 7 days even sometimes. So yeah.
Yeah, no, I'm just waiting for them puppies to hit log phase. And so hopefully that's, maybe less than a day, maybe a day. That's nice.
Good for you.
I think I'll just end it there.
There we go. Well, folks, thank you for tagging along, hanging in there, listening to us ramble about profiling and characterization and the pitfalls of species descriptions, I guess. If you're interested to hear more from us, go follow us on LinkedIn, Instagram, Blue Sky, YouTube. We've very recently, by the time the episode comes out, it's probably been a while, but we've started to get into the social media reel production. So if you want to see some funny memes, go check us out on Instagram. It was very nice talking to you again, Sam. I really enjoy our sessions.
Yes, always a pleasure.
And I hope to see you soon, cross-continent.
Yeah, we'll have to see if we can sneak one more in person in, but this might be the last one.
Oh, man.
If it's not the last, it's the second to last.
Aww.
Yeah.
Well, cool. On that happy note.
Goodbye, everybody.
Bye, everybody.